Hi guys, this is 8.2. So for PowerPoint 8.2, moles and mass conversions. So previously I did a video on calculating molar mass. So you need to know how to do that lesson first. So if you still don't know how to do that, you got to watch that video first. That's 8.1. All right, so we're going to convert between mass and moles. Okay, so a little background if we haven't talked about it already. So a mole is the SI unit for an amount of something. It's like saying a dozen, but instead of the number being 12, it's this number right here. 6.02 times 10 to the 23rd. Whoops, right here. 6.02 times 10 to the 23rd particles or things, right? We can have atoms, we can have molecules, we can have formula units depending on what it is. And again, that's in a previous lesson. And this is called Avogadro's number. All right, so the molar mass is the mass of 1 mole of a substance, okay? So we find this molar mass on the periodic table. We calculated that in the previous lesson. And the mass on the periodic table is how much that would weigh in grams if I had 1 mole sitting on a scale of that thing, whatever it is. And this is equal to the atomic mass. So let's say, for example, 1 mole of helium. We have 1 mole of helium sitting on our scale, which is 6.02 times 10 to the 23rd atoms of helium, and our scale will read 4.003 grams approximately. That's the average atomic mass, which we're not really going to talk about isotopes today, but so that's what the number we're going to use. Okay, so if the number of atoms is the same for each element, so if I've got a mole of boron and a mole of carbon, why is the mass different, right? If it's the same number, if I have a dozen boron and a dozen atoms of carbon, why is this mass number different? What do you think? Well, hopefully, maybe some of you are saying, well, there's different numbers of protons, which changes the mass. And you're absolutely right. Different numbers of protons for each element changes the mass because protons and neutrons, and also different numbers of neutrons, are really what is responsible for the mass. Okay, so real quick review. What is the molar mass of the following elements? You just rip out a periodic table, and you'll find that Ag, silver, is 107.9. Carbon is 12.0 and copper is 63.5. And now again, please try to round to 1 decimal place. If you want to round to a whole number, you can. Like this one is appropriate to round to a whole number, but just be careful if it's 0.4, 0.5, 0.6, you're definitely going to want to keep that decimal place there to keep your final answer more accurate. Okay, so again, this is a quick review. However, I need to talk about hydrates. Okay, hydrates just means if it has water in the formula. So it's going to look something like this. Sometimes it's a little asterisk and sometimes it's a dot. And usually there's some number, some coefficient in front of it. So here's how you do that. So if there is none, so like here, calcium hydroxide, for these compounds, you just multiply mass off the periodic table. By its subscript. And now things that have a, oh my goodness, what is this called? Parentheses, you take that subscript and you multiply it throughout. So there's 2 O's and there's 2 H's for this, but there's only 1 calcium. Okay, for a hydrate just means there is water attached to it. You add 18 multiplied by its coefficient. Now 18 is because that is the mass of water. I'm just telling you that. If you want to add it up yourself, you can. But oxygen is 16 and each hydrogen is 1, so 16 plus 2 is 18. You have to take that 18 and you multiply by the coefficient that's in front of it, okay? And then you add that in to whatever molar mass you already calculated for this. So for this one, okay, 18 times 3, and you're going to add that to the total of this molecule right here. So you're going to have a total of 213.7, and then the unit is grams per mole. And that's with those 3 waters added in. Same thing here, okay? We have aluminum and carbon and oxygens, and I've added all that up, and then I've added 2 waters. So 18 times 2 plus this whole thing gives you a total of 150 grams per mole. Please check me on that. Make sure that you guys can get that correct answer. If not, double check your process. And then for here, don't forget that you need to just multiply your subscripts throughout everything that's inside the parentheses. And again, unit is grams per mole. Okay, so now what we're going to do, let's see if I can change this. All right, so if the unit is grams per mole, right, here's what this means. The molar mass in 1 mole, grams per mole. Okay, so molar mass is grams from the periodic table, and that's how much it would weigh if I had 1 mole of it. So keeping that in mind, we're going to use 2 possible setups. So this is a ratio, number of grams in 1 mole, grams in 1 mole. So you either have grams on top with 1 mole at the bottom, or you have 1 mole on top with grams at the, did I say that right? 1 mole on top with grams at the bottom. These are your 2 possible setups. Well, Mrs. Teagues, how do I know which do I use? Well, it depends on what you're given. If you are given moles, right, you need moles and moles to be diagonal, and I'll show you that setup. If you are given grams, then you need grams and grams to be diagonal, and you'll use this setup. So let's try it. All right, so what is the mass in grams of 12 moles of aluminum? All right, so in order to solve these problems, as soon as you see the word grams, you know you're going to need some information off the periodic table, so make sure you have one handy. So I'm going to take my pen, and I am going to say, start my setup, and I always start with my given, which is 12 moles of aluminum. 12 moles of aluminum. And for right now, it's not super important if you tell me what it is. Later on, when we do molar ratios, it will be, but for right now, if you don't want to write aluminum, that's okay, but you do need to write moles so that I know that 1 mole has to go down here diagonal in order for those moles to cancel. So if 1 mole is at the bottom, then I need the grams of aluminum up at the top. And off of the periodic table, the number of grams is rounded to 27.0 grams. Now, I don't need to do grams per mole here because it already is. Per 1 mole is already down at the bottom. So I can just go ahead and erase this /mole because that's already what that is. All right, so once you do that, you type this into your calculator, and because my 27 is up at the top, you just say 12 times 27, and you get an answer of 324, and moles canceled, so my unit is just grams. All right, so for the next one, now we're going to start with grams. So start your setup, 4.50 grams, and you don't have to write calcium hydroxide for this, okay? But I do know that grams has to be at the bottom here in order for grams and grams to cancel. So I have to do a little bit of calculation here. With aluminum, it was straight up, just look at aluminum, but this is one of the calculations that we calculated here. So we have 1 calcium, and we have 2 oxygens and 2 hydrogens. So that total, once you add those up, is 74.1. Whoops, I wrote that in the wrong spot. Sorry about that, guys. Okay. It is right here at the bottom, 74.1 grams. Okay, and this is the total of this off the periodic table that I added up. That's my molar mass. And again, if you don't remember how to do that, go back and check my 8.1 video. Up at the top goes 1 mole. It's always 1 mole, for now anyway. Okay, so grams and grams cancels. I'm left with a unit of 1 mole. And now because my 74.1 is at the bottom, now I know I need to multiply. So 4.50 divided by 74.1 gives us 0.6, and you could round that, 0.061, and my unit is mole. Okay. All right, let's try another one. Mass in grams of 10 moles of lithium. Okay, again, I start my setup. I have 10 moles. Now, you have to write your units here, or you will mess up your fence post. I see that I have mole here, which means I have to put mole here diagonal in order to get moles and moles to cancel. Now I need to look on the periodic table for lithium, and I'm going to round that to 6.9 grams. That's a weird G. Grams. Okay, so again, I can do 10 times 6.9, and we get 69.0, and my unit left is, oh shoot, my unit left is grams. Okay, last one we're going to do. So we're going to calculate number of moles. We're given grams this time. 17.2 grams of benzene, which is C6H6. That's what this means, okay? Again, I need to calculate this molecule here. There are 6 carbons, there's 6 hydrogens. You add those up and you get 78.1 grams, and on top goes 1 mole. It's always 1 mole. All right, and so now because that number's on the bottom, we can divide, and I say 17.2 divided by 78.1, and I get an answer of 0.22, and my grams canceled, so I'm left with mole. Okay? All right, so the first classwork, or assignment rather, that I'm going to give you combines notes for 8.1 and 8.2, and that will be posted on Canvas. Please let me know if you guys have any more questions, and take care.